In this lesson, we're going to look at how acids and bases react with each other. As we'll see, the hydrogen ion from the acid reacts with the hydroxide ion from the base to form water. What's left over forms an ionic compound, which we call a salt. So as I just said, we have the hydrogen ion from the acid reacting with the hydroxide to form water. Because we're forming a neutral substance, these type of reactions are called a neutralization reaction. Acid-base reactions are actually a special case of a double replacement reaction. So some examples. What would be the products if we reacted hydrochloric acid and sodium hydroxide? So there's our reactants. Now remember, the hydrogen ion from the acid reacts with the hydroxide to form water. And then we look at what's left over. Remember, metals have to go first. So we can see that what's left over is sodium chloride. Let's look at another example. If we had hydrochloric acid and magnesium hydroxide reacting. So in this case, we have one acidic hydrogen and two hydroxides. So that means we have to have the same number of acidic hydrogens and hydroxides in order for this reaction to be balanced. So we're going to add a coefficient of 2 in front of the hydrochloric acid. So now we have two acidic hydrogens and two hydroxides, which will combine to make two water molecules. And then the part that's left over is MgCl2. The nice thing about doing it this way is it kind of writes the formula of the salt for you. We've got another example. If phosphoric acid and magnesium hydroxide reacted. So we write down the reactants. So here we have 3 acidic hydrogens and 2 hydroxides. And in order to have the same number, we're going to have to multiply the phosphoric acid by 2. So now we have 6 acidic hydrogens. Multiply the magnesium hydroxide by 3, so that we'll have 6 hydroxides. So when these combine, we're going to be forming 6 water molecules. And then looking at the formula, it's going to be Mg3PO4 twice. So in general, an acid plus a base is going to give you a salt and water. And a salt is any ionic compound that is not an acid or a base. And for whatever reason, this is a very important concept to understand. I was still getting questions about what do you get when you reacted an acid and a base when I was in graduate school. So I want you to commit it to memory so that when you're 90 years old, sitting in the park playing checkers or chess, your choice, and somebody jumps out of the bushes and says, "What do you get when you react an acid and a base?" I want you to be able to look them square in the eye and say that you get a salt and water. So that's a pretty short lesson. So here we have our wrap-up. Remember, acid-base reactions are called neutralization reactions. And that's because the hydrogen ion from the acid combines with the hydroxide from the base to form water. The second product, the other product, is always going to be whatever's left over, and that's going to be a salt, which is an ionic compound that is not an acid or a base. And then we saw how to use the numbers of the hydrogen ions and hydroxides in order to come up with the correct stoichiometric ratios for the acid and the base, which would then give us the correct subscripts for the salt. And in general, and we're going to commit this to memory, 90 years old, sitting in the park, you never know. The general pattern is that when you react an acid with a base, you get a salt and water. All right, so next time we're going to be talking a little bit more about acid-base reactions and how we can use them to determine concentrations of acids and bases. And so until then, thanks for listening.